before. So yeah, make sure to flip this one. So flip it to become 18 divided by z squared and then multiply and then simplify. So flipping it and then multiplying is key. Same thing here. So flip this fraction, the second one. So it's 30 over z squared, and then multiply it all together. So you multiply the tops, and then you multiply the bottoms, and then simplify. So to cross things out and make things smaller. So like here, 5 times 30 is 150. So then do 3 divided by 150. The simplified version would be 1 over 50. Multiply and simplify, multiply the tops together here, multiply the bottoms together, and then cross things out and simplify it. Here, multiply and simplify, multiply the tops, multiply the bottoms, and simplify. So cross x's out, and then 6 times 25, do that, and then divide that result by 5. Multiply and simplify, do 3z cubed times 32, then 4 times z squared, cross out z's, and then do 3 times 32, for whatever that is, divide by 4. Then here, perform the indicated operation and simplify. You want to do common denominators, so you want to have common denominators for both fractions, so make sure to do common denominators. Then here, common denominators again. So multiply the bottoms together, then multiply the tops by the opposite bottom here. Yeah, and then subtract the tops. Here, the bottoms are the same here, so you can just add the tops together and you'll get your answer. Here, the bottoms are the same, so you just add the tops, get your answer. Here, perform the indicated operation, simplify. You want to make the bottoms the same here, so you want to find a number that will make the bottoms the same. So figure that out, and then add the tops together. Here, multiply the bottoms together, multiply multiply the opposite bottom by the top, by the opposite top, the opposite bottom by the opposite top, and do the crisscross method there. Here, common denominators again, then add the tops together. Common denominators again, add the tops together once you have common denominators. Here, they have the same denominator already, so you can just add the tops. Here, make a common denominator for both, add the tops. Here, make a common denominator and then combine the tops. Here, make a common denominator, combine the tops. Here, make a common denominator, combine the tops. Here, make a common denominator and combine the tops. Here, you would want to do the crisscross method again. So, sorry, not the crisscross method, but you would flip the right fraction and then multiply both together. So the next thing is we'll go through lesson 5 here. So here you would find something common in both equations. So the 14m minus 2m squared, you want to find something common here that you can factor out. So what's common to these two terms here? Figure that out, and then you can take it out of the formula. And here, figure out what's common to these numbers and letters here. Figure out what they have in common, and then take that out. And then you can get one of these answers once you've done that. Then factor by grouping. So you want to here just I recommend combining these together because they're both x squareds. Combine them together and then factor using, if you use decomposition, if you use the algebraic method, if you use the Australian method, I recommend all of those there. Factor completely. You can do this. Australian method is highly recommended. I recommend using the Australian method for that, or decomposition. Here, you can just factor something out, so you can figure out what's common to each of these two terms and then just factor it out. Here, you could use the Australian method of decomposition, whatever you like whatever's best for you. Here, you could so here, this is difference of squares. So you could use difference of squares to factor this. And then here you can use the Australian method. Here you can factor out something common to figure out what's common across all of these numbers here. Here, figure out what's common across these numbers and then use the Australian method. Here, just use the Australian method. Or just, yeah, so I recommend using the Australian method for this one. Here, it's difference of squares. So figure out, so you can figure out, you can take out the 4 and then go from there. And then find what, and then use the Australian method. Here, you can use the Australian method again. Here, Australian method also. Here, Australian method. So I recommend using the Australian method, and Khan Academy has some good tutorials on the Australian method. I recommend trying that. There's a lot of good tutorials on YouTube on Australian method there. But yeah, Australian method you can use for most of these, pretty much, or whatever you feel comfortable with decomposition if it's Australian method. And then here you would have to put this into an algebraic equation and solve. Here, put this in an algebraic equation and solve. So yeah, those are good ones to do. And then quadratic equation. So a lot of these will require, so you'll have to use, so in this case, to find a 0, if this is a 0, you plug the 2 in for x here. And then if this all equals 0, then it would be a yes. If it doesn't equal 0, it would be a no. So plug in the 2 into this equation for x, and then figure out if it all equals 0. If it equals 0, then a yes. If it doesn't equal 0, then no. So do that for all of them here. So 2 here, plug that in. If the equation equals 0, then it's a yes. If the equation doesn't equal 0, then it's no. Then here, determine the remainder using the remainder theorem. So here you would want to do, so minus 3 plus 3 is 0. So put minus 3 in to the equation here and figure out what it would equal, and then it would be one of these answers. And then determine if this is a quadratic, bringing everything to one side, and then determine if it takes the quadratic form. Here, find all roots using the factor theorem. So you can test numbers in. So you can test all these numbers in these. So put these numbers in into the equation and see if it equals 0. If it equals 0, that's a root. So test all these numbers, plug all these numbers in the equation, and whatever numbers give you 0 as the answer will be a root. And then here, quadratic equation, here, you want to put it all on one side. So bring the 8 minus x over to the left side, and then find out what a, b, and c are for the quadratic equation. Perform the indicated division by synthetic division. So Khan Academy has some good videos on synthetic division I highly recommend watching. Here, solve the equation using fractions. So make common denominators for all of these and then add the tops together. Here, make common denominators for all of these and then add the tops together. Here, solve the equation, make common denominators for everything and add the tops together. Here, make common denominators for everything, add the tops together. Here, make common denominators for everything, add the tops together. And yeah, so common denominators. Factoring, use the Australian method. Factoring, use the Australian method. Here, use the quadratic formula. So the quadratic formula, use that. Here, use the quadratic formula. Here, make common denominators, and then use the quadratic formula. And then here, put -2. So -2 plus 2 is 0. So -2, put -2 in for x here. And then if it equals 0, then it'll be yes. If it's not 0, it's a no. So that's how you do that one. And then slope and graphing. So here, vertex of the parabola, you want to use, so for this one, you want to use completing the square. That's very effective, and I'll post a few videos on that. Vertex of the parabola, completing the square again. Vertex of the parabola, completing the square. So finding the vertex, the best way is completing the square. Horizontal and vertical intercepts. To find the vertical intercept, you got to set x equal to 0. If you want to find the horizontal intercept, you got to set y equals 0. So yeah, so you set, to find the y-intercept, set x equal to 0. To find the x-intercept, set y equal to 0. Yeah, and here you'll have to actually use quadratic formula. So plug all this into the quadratic formula. And then, so to find the x-intercepts here, you plug it all into the quadratic formula. And then to find the y-intercept, set x equal to 0. And then here, you would want to find the x-intercepts, plug it all into the quadratic formula, and then to find the y-intercept, set x equal to 0. Same thing here. To find the x-intercepts, put everything in the quadratic formula. To find the y-intercept, set x equal to 0. Graph the parabola. So I'd recommend use the quadratic formula first to find your x-intercepts, and then to find the y-intercept, set x equal to 0. Plot the intercepts, and then connect the dots. That's what I recommend. Graph the parabola, same thing. Use the quadratic formula to find the x-intercepts, and then set x equal to 0 to find the y-intercept, and then put the points in the graph, connect the dots. Same thing here. Like, this one's a lot easier. To find the x-intercept, you set y equal to 0. To find the y-intercept, you set x equal to 0, and then connect the dots. Graph the parabola, factor this to the Australian method, or use the quadratic formula to find the x-intercepts, and then to find the y-intercept, set x equal to 0. Graph the parabola, set x equal to 0 to find the y-intercept, set y equal to 0 to find the x-intercept. Same thing here. So this one's actually different. So use the factor this with the Australian method to find the x-intercepts, then set x equal to 0 to find y-intercept. So yeah, you can use that. And then parallel and perpendicular. If it's parallel, the lines are the lines move in the same direction, and they have the same slope. That's parallel. So they are moving in the same direction, but perpendicular is when they're moving in opposite directions. Sorry. So perpendicular, actually, I'll rephrase. Perpendicular is that if they're moving, one's moving horizontal, one moving vertical. So like, basically, to find a perpendicular one, you gotta flip the slope and make it negative. So do that. So that's what you have to do.